Hello! This is the Physics Chapter 8 Final Exam Review. You'll need to have your questions out. Sheet looks like this. We're just going to work these 5 from Chapter 8. And I made a bit like the other videos, I made a sheet with a bigger font, so hopefully you can see it on the video. So number 1 says a radio flyer wagon sits at the top of a 50-meter hill, coasts down the hill and back up a 20-meter hill. What's the wagon's speed at the top of the second hill? Okay, so this is a total energy equals total energy problem. So the total energy at hill 1 has to equal the total energy at hill 2. So that's the potential energy at hill 1 plus the kinetic energy at hill 1 has to equal the potential energy at hill 2 plus the kinetic energy at hill 2. All right, it doesn't have any kinetic energy at hill 1 because it's just sitting at the top of the hill. It's not moving in the first place. It could be, but it's not. Maybe the next problem it will be. But it does have potential energy. And it has both. It has height, and we're trying to figure out how fast it's moving at the second hill. So that's going to be potential energy, remember, is mass times gravity times height. And that's going to equal mass times gravity times height at hill 2 plus 1/2 mv squared. Okay, we have a mass in every single one of these, so we can cancel that out. Gravity 9.8. The first hill is 50 meters. That's going to equal 9.8. The second hill is 20 meters. All right, you can kind of tell I wrote these problems because I didn't put a bunch of decimals and stuff in it, plus 1/2 times v squared. All right, so this is going to be 490. All right, I'll dispense with the units for just a minute. Is equal to 196. 9.8 times 20 is 196 plus 1/2 v squared. Okay, so if you subtract 196 from 490, you'll get 294 equals 1/2 v squared. Multiply both sides by 2 and you'll have v squared is equal to 588. So velocity, then, if you take the square root of 588, is 24.25 meters per second. All right, not bad at all. Okay, let's go to problem number 2. Okay, problem number 2 says a 2000 Nissan Altima travels at a speed of 18 meters a second at the top of an 80-meter hill. So this time it's got an initial velocity. It coasts down the hill. What is its speed when it's 50 meters below its starting point? Tricky. What's the height if it's 50 meters below 80? Well, it's 30, so don't accidentally put 50 into the second height. But it does have an initial velocity, so we'll have a few more numbers to deal with on this one. So we have total energy hill 1 is equal to total energy hill 2. Potential energy hill 1 plus kinetic energy hill 2 is equal to hill 1. Potential energy hill 2 plus kinetic energy hill 2. We've got numbers for all of these this time, so nothing is 0. So this is going to be mgh hill 1 plus 1/2 mv squared is equal to mgh of hill 2 plus 1/2 mv squared. And this is the second velocity. All right, all the masses cancel. Yay. Because I don't think we don't have it, so it'd be hard to put it in. And we're in meters, so we'd have 9.8 Hill 1 is 80 plus 1/2, and that initial velocity is 18. Don't forget to square it. Is equal to 9.8. Hill 2 is 30. Remember, it is 50 meters below its starting point. So 80 minus 50 is 30. Plus, and then 1/2 v squared. We're trying to figure out the speed again, the second speed. Okay, 9.8 times 80. That's going to be 784 plus 1/2 times 18 squared is 162. And that's equal to 9.8 times 30 is 294 plus 1/2 times v squared. All right, if we add those two together, then subtract 294, you get 13. Let's see, and you also multiply by 2, right? Subtract 784 plus 162 minus 294, and then multiply that by 2, both sides by 2. You would get 1304 is equal to v squared. So take the square root of that, and you'll get 36.1 meters per second. Okay, so the only difference between this and number 1 is we had an initial velocity, so don't let that throw you off. And I worded it a little funny, okay, to where you had to, instead of 50 meters, it's 30 meters because it's 50 meters below its starting point. So just don't let something like that get you. All right, let's go to number 3. Number 3 says a piñata. Oh, I even put the little funny character there. Hanging on a string is whacked with a baseball bat. If the piñata reaches a height of 1.1 meters, what is its initial speed? All right, on our test over this section, we had, I think it was a melon. All right, so this time a piñata. So let's, I don't know, funny shaped piñata. Right, and somebody hits it, it ends up over here. The difference in height between those two is 1.1 meters. So we'd have a total energy before it gets hit has to equal the total energy when it's at its maximum height here. So that's going to be the potential energy plus the kinetic energy equals potential energy plus kinetic energy. Now this kind of problem is not, there a lot of stuff is 0. So we don't have any height here in situation 1. And we don't have any motion here in situation 2 because it's at its maximum height. It's suddenly still momentarily. So that is 0. So I'd have 1/2 mv squared is equal to mgh, right? And that's going to be velocity 1. The masses cancel. So I have 1/2 v squared is equal to gravity times the second height. All right, I want to know the initial velocity. So if I multiply both sides by 2, it'll just be 2gh. All right, and that's the second height. So that's the square root of 2 times 9.8. The height is 1.1 meters. All right, when you put that in your calculator, you get 4.64 meters per second. All right, so moving right along, let's go to number 4. Okay, Okay, number 4 says a 55 kilogram sophomore curled up in the fetal position on the gym floor is given a good swift kick. I wonder if any of you juniors and seniors would like to do that to the occasional sophomore. How far will this drag of humanity slide if he is kicked with an initial velocity of 27 meters per second? Wow, that is quite a boot. And we have kinetic coefficient of friction of 0.2. All right, well, this is going to be our other equation from chapter 8. We have total energy final is equal to the initial total energy minus the work done by friction. Okay, well, eventually that drag of humanity sophomore is going to come to a stop, so there won't be any energy in the end. So if I move the work done by friction over to the left, we'd have work done by friction is equal to total energy initial. Okay, so work done by friction is friction times delta x, right? Force times delta x. And that's going to equal, it doesn't have any height, it's on the gym floor, so it's going to be just 1/2 mv squared. If it did have height, we would have to put that in, but no height. So friction is just the normal force, right? Normal force times mu, which is normal force is just the weight. So that's mu times mass times gravity times delta x is equal to 1/2 mv squared. The masses cancel. All right, and we're trying to figure out how far is this drag of humanity going to go. All right, so delta x is equal to 1/2 v squared over mu times g. Just doing the algebra, bring that mu times g underneath. So the initial boot was 27 meters per second. Don't forget to square. The gym floor was very slick. It's just been recently waxed, I guess. 0.2, goodness. And gravity 9.8. All right, and that is 186 meters. So that is way further than the gym is. So I hope someone opened the door so that they could get out the door and not hit the wall with some impressive speed. Probably make it all the way out to the dumpster if kicked properly. And that's our next problem. We're assuming that the drag of humanity did make it to the dumpster. So let's finish up chapter 8. And in this problem, we're going to use the power equation. So power is the change in work over change in time. So it says, how long would it take to lift the sophomore in the previous problem 2 meters off the ground in order to be placed in the dumpster with a forklift that generates 500 watts of power? That's a weak forklift, I'll tell you that, because a hairdryer is 1,500 watts. So, whatever. Okay. So we know, if we want to know how long, we're solving for the time. Work is just force times distance. F delta x over delta p. We already have p, the power is 500. Well, what is the force? Okay, it's just the weight of the sophomore, okay? So it's weight times delta x. It didn't give you how many newtons of force, so the only thing it can be, the forklift has to lift at the weight. Well, what is weight? It's mass times gravity. Okay, so that's going to be, mass was 55 kilograms. So a kilogram is 2.2 pounds, so 50 times, that'd be 120, and that's about about 130, 135 pounds. That's not unreasonable. Gravity 9.8. The distance to the dumpster is 2 meters. That's pretty reasonable, 6 feet, a little over 6 feet, 6.5 feet. I think I thought this through a little, when I wrote it about a dozen years ago. Over 500 watts. When I wrote it, the sophomores at CCA were populated with some particularly mischievous students. So that's why I wrote it. And that is 2.16 seconds. I think that is true today as well, but not as bad as it was back then. Back then it was unbelievable. Boy, could I tell you stories. All right, and that does it for the Chapter 8 review. I will talk to you in Chapter 9.